Does Ladyada.
Hey everybody, welcome. Oh, no, cool animations in the background.
Yeah.
Welcome to the desk of Ladyada. It's me, Ladyada, on this lovely Sunday night. It was really beautiful weather this weekend, so we did a lot of walking. We're like moving our feet, which is good. Makes our brains work a little bit better. But we're at my desk right now. So what kind of electronics have I been up to? So I thought I didn't design any new boards this weekend, but I did design a whole bunch of boards this week while I was at work. So thought we would talk about some of those. But first up, is there any news or updates? Anything from you want to chit-chat, Mr.
No,
Ladyada?
full speed ahead.
Okay.
Full week of shows and more. Let's do it.
Okay. So one of the things that, I've kind of almost every week that we've done Desk of Ladyada is STEMMA Sunday, and this is no different. But one of the things I was working on is actually a board that I'd forgotten about. Because usually I have all my PCBs, when I order them, I keep track of which PCBs I've ordered. But in this case, I didn't order a PCB, and that's why I forgot about this design that I had done. So let's go to the computer screen. Okay. So one of the things that's neat about, doing STEMMA QT boards is what I'm trying to do is have a standard layout and size for boards. So all of our breakout boards, they're plug and play, but they're also physically about the same size as much as possible. I try to fit them into this size with connectors on the sides, and then the pins on the bottom, and the pins I try to make them in the same order. So it's power, 3 volts, ground, clock, data, and then other control pins. And then I try to have 4 mounting holes, or at least 2 mounting holes at the top. And one of the neat things about doing this is, first off, people have always asked for actually a long time. They've asked, hey, can you make the boards have the same pinout so it's easier to swap them in and out? Because we'd have boards that were very similar but had slightly different pin orderings. Because I would just whatever order at the bottom, I would just kind of decide on the fly basically. I'm trying to think of I think the MCP. Yeah, like this one happens to be power, ground, clock, data, and this one also has to be power, clock, data. But let me see. It's sort of an early board that I designed. I think the Scilabs UV. Yeah. So like for this one, for example, the order is not. It's power, ground, then 3 volt, then into LED, clock, and data, and that's just because it was just easier to route that way. But by trying to make all of the boards the same pinout, if you do want to stack, of course you can stack them or you can chain them together. But another side effect is by going with a standardized layout is I can actually sometimes share the layout, the PCB itself, between boards. So this is the BME 280, and then if I look at the BME, sorry, that's the BMP 280, and then if I look at the BME 280, you'll see that the layout is identical. The sensor in the middle is a little bit wider, but actually use the same footprint. But all the other parts are, I can kind of flip between them, and you can see the PCB is actually the same. I actually use the same stencil and the same layout for both PCBs, even though the sensor is technically different. And then also the DPS 310. When that came out, this is from On Semiconductor. This one, hold on. This one is also, as you can tell, the exact same pinout and the exact same layout for the components. All I do is change the silk screen to say from BME 280 to DPS 310, because it's the same. This is clearly made by this company to be compatible, and especially now that there's a silicon shortage. Having these compatible parts is like really, really nice, and I really enjoy it. Colin did a video actually this week. One of his Colin's Lab videos was about, or will be on Monday, about how op amps are all the same pinout. If you are using op amps in DIP or SOIC or TSOP, single, dual, and quad op amps, they all use the same pinout configuration. Like, thankfully, the industry decided, okay, here's how we're going to configure power, ground, plus minus output for all of the different sub op amps in op amp array. That's not true for transistors. Transistors do not necessarily have a standard pinout. Like BEC is very common, but they can vary. They're not always the same. I wish that all sensors would be the same pinout. Of course, they're not always, but this one thankfully is. And so the sensor that I forgot about is, we have a couple of these infrared sensors. It's actually quite popular. The infrared sensors from ST, the VL6180 came first. I think it's about a 2 meter range. Sorry, a half meter range, and the VL53L0X about 1 meter range. This sensor, what's funny is you can look in the animation here, the GIF. It's the old board, but when we revised it, to be a STEMMA QT sensor, you can see it got turned into a new board. You also see, the layouts I use between sensors is very similar. I have the regulator over here, capacitors, LED. I like to put the sensors in the middle as much as possible, and then the shifter over here, so I can actually recycle. The layout is almost identical. And then there's actually an update to this sensor chip, the VL53L1X. And so if you go to the overhead, can you go to the overhead?
Yeah, sorry.
This is the
Yeah, you can even move that around a little bit.
yeah. Zoom in. This is the this is a very small sensor, but you can actually see it. I can't see it, but you can see the IR LED being emitted and then detected on the other side. So there's two shiny elements, and one's the emitter, the bottom one, as you can tell, and then the receiver's at the top. So this is doing a micro LiDAR. So even though this is the VL53L0X, this is actually the 1X, the next generation of the chip, which again, thankfully, is the same pinout. The 53L3 is not, eventually they don't necessarily use the same pinout. But what's cool about this is, first up, I don't have to relay out the board. That's great. I also get to reuse the stencil and the pick and place program. And stencils are not expensive, but they are like $300 or $400. The pick and place stencils, they're framed stencils, they're laser cut, and they're gold coated. They're quite nice. And so whenever you can have the same layout, I like doing that. And then you just change the silk screen. And when you tile it, you tile it to be the same exact layout. I verify it, before the PCB to make sure I got that layout tiled exactly the same. And then it just saves me so much effort. I can also reuse the same tester. So like a lot of the common work gets recycled, which is quite nice. So that's what I've got for that. And then we can, I can start sort of moving into the great search, or I can talk about the great,
Yes, let's do great search.
Okay.
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Adafruit and DigiKey team up, and Ladyada uses their knowledge of searching the DigiKey site to find the parts you need. Ladyada, what is this week's Great Search?
Okay, so we actually just talked about using the same board layout with parts that have the same pinout. So BMP280 and DPS310. I've talked about the VL53L0X from ST, and there's the 53L1X or 1CX. So again, sometimes companies will reuse or competing companies will use the same pinout and package, which is like really awesome because again, you don't have to respin a board, you don't have to respin a tester, you can recycle the same layout. So this week, I was tasked with, and you'll see why this is, in thematic. We just ran out of ADXL 377s. This is a really cool chip. Analog Devices, of course, is one of the first companies to make, analog and digital accelerometers. They're famous for it. This is a 200G accelerometer. Now, most people don't use 200G accelerometers. They use, 2, 4, 8, maybe 16. 32G is kind of a high end, for like, sports and some automotive. But there are, rocketry and mechatronic and robotic reasons that you'll want up to 100 or 200G output. This accelerometer, it's funny, I think this actually uses the same pinout as the ADXL 326. I think this one, maybe it's not, but it's very similar. They have a lot of LG, it's 16 LGA sensors. And I really like this one because it was a 200G analog output. And I was like, well, I'd like to see if I could find a replacement. Analog is kind of nice. It's ratiometric, which means that in whatever within the 3.3 volt output, it's you can use that 3 volt output into your analog reference for your microcontroller, and then exactly halfway is 0G, and then as it all the way to 3.3 volts is plus 200G, all the way down to ground is negative 200G. So one thing that was interesting is, one reason that you will have, I like to, when a sensor becomes obsolete, so this just became obsolete, it's no longer manufactured, I sometimes like to look at the obsolescence document. This is interesting. So, there is a last time buy date, which just passed. But I'll say that, again, with the silicon shortages, these last time dates, they're, what they mean and what, it's, whether you can actually get them is different. You used to have a little bit of time, you used to be able to get the parts. And now I'm finding that when it's gone, it's gone, that end of line time. So, I think we have a couple more on order, but I did want to find a replacement. What I thought was interesting was that this ASIC process is being discontinued by the foundry. I have seen this happen, and when this happens, you're really, there's especially like interesting analog process chips. I'll see that they're discontinued, and it's not like, they're not popular. It's like, no, that process, that there's not enough companies using that process. The wafer foundry, the company that makes the silicon, is actually going to shut down that line, and they're going to replace it with a more profitable line. This happens, and when it happens, you are totally SOL. I think there's a couple Maxim chips. I think a couple of the analog chips that I got from Maxim, I remember, were also shut down for similar reasons. So that said, I was like, at first I was thinking, okay, well, let's find, analog XYZ, chips. I didn't select plus or minus 200G because, maybe there's 100G available. And of course I want surface mount. So let's see. And then let's look also, of course, only at active. So these are the analog ones, and you'll see, some of these are the, old mil spec ones. These are, some of them are quite ancient. The 335 series we've been carrying for quite a while. But I thought maybe let's look at, the high G rate. So maybe, 50 to 500G. And unfortunately, they do exist, but they're all like super expensive. They're like about $100 a piece, and they're available only from TE. So these are very specialty parts. This is kind of where I sort of have to make a decision. Look, this analog, I'm not going to be able to get an analog version of this accelerometer, but maybe I can get a digital version. Maybe I have to give up on I do like the analog ones. I think they're really cool, but I also know when to give up. So going back here, we're just going to go to accelerometers. I only want active ones because I don't want to have to go through this whole process again so quickly. And then I want X, Y, and Z. I really only want triple axis accelerometers. They're very common these days. And then acceleration range, I want to see maybe, 50 to 500. 6,000 G is kind of bonkers. I'm not really ready for that. So let's do 50 to 500. And you'll see that, there are a couple really expensive, industrial use ones, but there are also a couple of inexpensive ones as well. Looking at price, there's the LIS series. I'll say you can't get any accelerometers from ST for next year, so I'm going to skip that one. The LIS 200. I think we stock this one, but this was kind of interesting. Again, I really like analog devices for their accelerometers. So this 200G accelerometer, first off, they have a lot in stock, which is really nice. Another thing that is cool is that they have this package, the 14 LGA, and the 14 LGA pinout is shared with almost all their other accelerometers, which is why I was talking about shared pinout. So this is the pinout for the accelerometer. You can see it's, not all the pins are used or some reserved, but it does have 2 interrupt pins, SPI port, and I2C shared, which I like it when sensors are like, look, we can do I2C or SPI, because I feel like they really, I2C is tough to bit bang, but SPI is quite easy. SPI is also faster if you really want to get the data out much quicker. Of course, you can have multiple sensors on SPI. So I'm really I'm always in love when sensor companies have I2C and SPI dual purpose interfaces. But thankfully, this LGA, when I saw this, I was like, ooh, I wonder, hopefully, is that going to be the same as the other LGA accelerometers, ADXL 345, which is ancient and historic, right? This one. And also the 343, which is kind of like the next gen of the 345, and we featured this on the Neo Trellis in one of the Ada boxes. It's a very nice, very low cost accelerometer, and again, analog devices, they do a really, really good job with their accelerometers. They're not the cheapest, but they're really reliable, very quiet, and you get really good performance out of them. So thankfully, this board, the 345, which is the same pinout as the 343, is usually also did a feather wing of this board. These are the same pinout, and so the 375, I was like, this is an easy. Normally I wouldn't spin up a whole new board for this accelerometer, but if I can reuse that same design to all 3 of them, I'm loving that, because I really like to have one design. So I did. Let's see, it's going to be recent. So for the ADXL, and the ADXL 343, it's actually one of the last boards that we did before we changed over to some of our standard STEMMA QT format. So I was like, you know what? Let's make a breakout for this board, and while I'm at it, revise the 345 and the 343. So this is what I came up with. It's a little bit of a tight fit, but it does fit. Let's do top silk. So the accelerometer's in the center. We've got 4 big mounting holes, I2C down here, and then the extra SPI pins up here, and then everything fits. And there's a little bit of room for the part number, and then of course on the back I can have even more part number info. But and maybe I'll over here in the corner I can maybe fit an XY coordinate marking. But yes, it's the design I made, and that's the accelerometer I picked. I wish there was an analog 200G accelerometer, but I think the days of analog output accelerometers is kind of over. But I2C SPI is available, and I think not only is this chip going to be pin compatible, but it's likely going to be very close software-wise as well. I'll probably be able to reuse the Python and Arduino drivers that we've written for the 3XX series for the 200G accelerometer. So I'm going to pick some of those up and spin out this board, and I'll mount it on, and it'll just work.
That's a great search.
Where in the world is that part I need? The great search with DigiKey.
Okay.
All
20
right.
minutes on the dot.
That's our show for tonight, everyone.
Yeah.
Thanks for joining us on this desk of Ladyada. We'll see you in all the ways, shapes, and forms all throughout the week this week. Bye-bye.
Go back to watching the Tonys.